So in this video I'm going to try to explain the method of bisections. So we have the intermediate value theorem, and there's a corollary to the intermediate value theorem, and that corollary says that if you have a closed interval from a to b, and if you plug a into your function f, that has to be continuous on that closed interval. If you plug a into f and b into your function f, and then you take the product of the outputs. If the product of the outputs is negative, then you're guaranteed that there has to be at least one input c on the interval from a to b, such that f of c is equal to 0. In other words, c is a 0 of the function on the interval. And in a picture, this is what it really would look like. We have a closed interval from a to b, and we have a function that is continuous. We can draw it without lifting our pencil. It's continuous on that interval from a to b. So when we plug in an input of b, we get an output f of b. And in this case, clearly, because we're above the input or x-axis, we see that f of b is going to be a positive number. And down here, when you input a, you get an output of f of a at this point. But clearly f of a is going to be less than 0 because we're below the x or input axis. So when we take the product f of a times f of b, we're going to get a number that's less than 0 because we're taking a negative number and we're multiplying it by a positive number. So the idea is that for the method of bisections, that if you can find this closed interval from a to b such that there is a sign change, and the way that you check for the sign change in the function output is you just take the product of the function values, and if it's, I put 1, if it's less than 0, you know that the product was negative, which means one of the two numbers is negative, one of the two numbers is positive, and if you get a sign change going from negative to positive, if the function's continuous, you have to cross the x-axis at some point, guaranteeing a 0. So the method of bisections utilizes this idea to find the 0 or approximate the 0 of a function. So this says, use the intermediate value theorem to verify that the function x cubed plus 2x minus 1 has a 0 on the interval from, or the closed interval from 0 to 1. Then use the method of bisections to approximate it to the nearest hundredth, and carry out all intermediate computations 6 decimal places. So the first piece is to verify that we have a 0, and that's simply a matter of plugging 0 into the function. So we get 0 cubed plus 2 times 0 minus 1 is going to equal negative 1. And then plug your other interval bound into the function. So f of 1 equals 1 cubed, 1 plus 2 times 1. 1 plus 2 times 1 is 3, minus 1 is 2. And then we want to notice that the product f of 0 times f of 1, which is going to equal negative 1 times 2 is negative 2, is a negative number, which is less than 0, which means that we must have a 0 on the interval from 0 to 1. The function must cross the x-axis. And then our job is to approximate that crossing to the nearest hundredth. So if I step out into GeoGebra, what I've done here is graphed the function x cubed plus 2x minus 1. Here it is. And you can see that on the interval from 0 to 1, the function does indeed have a 0. It has an x value that generates an output of 0. And our job is to estimate it to the nearest hundredth. So I used my graphing calculator to get my estimate to the nearest hundredth. I can see by looking right here, my estimate's going to be 0.45. So I want to run the method of bisections until I get a 0.45, which will mean that I have given an estimate to the nearest hundredth. And we found that when we plugged in, we had the interval from 0 to 1. So the interval from a to b, or 0 to 1, when we plugged in 0, we got a negative number. So I'm putting a negative sign right here to indicate that 0 generated the negative. And I put the plus sign here to indicate that when I input 1 into f of x, I got positive 2, I got a positive number. So we need to keep track of whether a number is generating an even or odd number. And the idea is we know there's a sign change from negative to positive on the interval from 0 to 1. So we know there's a 0. And really what we're doing is saying, hey, we know there is a 0 on the interval 0 less than x less than 1. On that interval, between here and here, there's got to be a 0, and we need to estimate it. So here's how the method of bisections works. What you do is you find the midpoint of the line segment from 0 to 1. And to find the midpoint of a line segment, we just take the average of the two numbers, the arithmetic average. So I'm going to go 0 plus 1, take that sum, and then divide it by 2. And I'm going to do this in a spreadsheet so that it expedites the arithmetic. Oh, the other thing to notice, because it's said to carry intermediate computations to 6 decimal places, I have gone in under options and turned my rounding on to 10, which is the first option I have that carries my rounding in my pictures out to at least 6 decimal places. So the midpoint of the line segment, here's the line segment from 0 to 1. We know that the 0 of the functions between those two numbers. So what we do with the method of bisections is we find the midpoint. So I'm going to go equals so that the cell knows I'm going to do a calculation. And then I'm going to say take the 0 in cell B3, add it to the 1 in cell C3, take that result, make sure I got parentheses on both sides, I do. Take that result and then divide it by 2. Find the average of the two numbers. And so the midpoint, or the average of 0 and 1, is going to be 0.5 in this case. So what I want to do is see what the sign of the function is at 0.5. So I need to take this 0.5 right here and plug it into my function f of x and see whether it generates a negative output or a positive output. So in GeoGebra, how I'm going to do that, because I gave my function a name, f of x, right here, I can use the name of the function. I can go equals f of, and I open that parentheses, and now the cursor's inside the function notation. And instead of typing in 0.5, I'm going to click into the cell and feed the function the cell, which effectively feeds it the number, and then I hit enter. And what I see is I get 0.125. The number isn't as important as the sign of the number. I see that the sign of the number is positive. So I'm going to replace this positive number. I knew the 0 was between 0 and 1. Replace this positive number, equals, replace it with the midpoint of the line segment, because the midpoint also generates a positive output. And I'm going to keep the 0 that I already had. And what I'm doing is I'm saying that there's a sign change now because 0.5 generates a positive number, and I know 0 already generates a negative. I know there's a sign change between 0 and 0.5. So I know that the 0, if I go in here and change this 1 to 0.5, I know that the 0 lives on this smaller window. I know the 0 is between 0 and 0.5 now. And then what we do with the method of bisections is we iterate this process until both the left and the right endpoint on the interval agree out to 2 decimal places, or 0.45. And then we will have gotten our estimate for the 0 to 2 decimal places. So we just keep doing this process. I have a new interval from 0 to 0.5 on which I know the 0 lives because it generated a sign change. I now want to calculate the midpoint of these two. And what I want to do is just drag the formula down that I used before to calculate the midpoint. So I click into the cell, hover over the square, and drag down. And now the formula that I used to calculate the midpoint here is applied to these two numbers, which gives me the midpoint. The halfway place between 0 and a half is a quarter. And then I want to know, does that give me a positive or negative output on my function? So I'm going to drag my formula down. My formula said feed the number in the cell into the function. So I don't need to do it every time. I just drag the formula down and I see, ooh, I get a negative output when if I plug 0.25, the new midpoint, into the function. So this time I'm going to replace 0, which was the old number that generated a negative output. I'm going to replace 0 with 0.25, a number that generates a negative output. So equals the number in the cell that's generating the negative output. And I'm going to keep the 0.5 for the other endpoint because it's generating the positive output. And now I know that there's a sign change on my function between 0.25 and 0.5. So my midpoint needs to live between those two. So I'm going to update this just for pedagogical purposes. Replace the 0 with 0.25, a number that also generates a negative output, but that's closer to 0.5 than we were before. And now I know the 0 lives between those two. And we just iterate this process. Calculate a new midpoint. Plug the midpoint into the function. See that the midpoint, the new midpoint, generates a negative output. Replace the old left endpoint that generated the negative output with the equals, the number that is the new midpoint, and keep the right bound, which was generating a positive output, so that there's still a sign change between these two numbers. And now I've squeezed in even further. If I replace 0.25 with 0.375, I have a window that's closing in on the actual 0. I have a window that's closing in on that 0. And we iterate again. Calculate the midpoint of these two numbers by dragging the formula down. Take this new midpoint, plug it into the function using the spreadsheet. Ooh, it still gives me a negative result. Replace the left endpoint that was giving me the negative result with the new left endpoint. Keep the right endpoint. So replace 0.375 with 0.4375. And I've narrowed the window around the actual 0 even more. Do it again. New midpoint, function at that midpoint. Ooh, now it's a positive number. So now I'm going to keep the left endpoint that was generating my negative number. I'm going to replace the right endpoint with the new midpoint that generates the positive output. I'm going to update my right endpoint. I got 0.46875, and I've squeezed in even closer to the 0. Calculate the new midpoint. Evaluate the function at the new midpoint. Ooh, this time it's negative. Go over here. Replace 0.4375, which generated a negative output, with 0.453125. Keep the other midpoint that was generating the positive result. Calculate a new midpoint. Plug that midpoint into the function. It generates a positive result. Now keep the left endpoint. Replace the right endpoint with the new endpoint. Calculate the new midpoint. Plug the new midpoint into the function. It generates a positive result. Keep the left endpoint that generates the negative result. Replace the old right endpoint with the new right endpoint. And now I can stop. This is the point where I can stop because I have 0.45 on both the left and the right endpoint, which means that my 0, my left endpoint is what? 0.53125. My left endpoint is there, and my right endpoint is 0.45703.125. So now I know that the 0 is between those two numbers. 0.45 is a good estimate for the 0, which occurs at 0.25. So really the method of bisections is simply a matter of squeezing the interval in closer and closer and closer to the 0. We could keep iterating this. If we wanted 3 decimal places of precision, we would just calculate another endpoint, and we would go until these two numbers matched out to 3 decimal places. So take this number, plug it into the function. It gives a positive result. Keep the old left endpoint, replace the right endpoint with the new midpoint. Get the new midpoint, plug it into the function. It generated a positive result. Keep the old. Use the new. Find another midpoint. Calculate the sign. It's still positive. Keep the old. Use the new midpoint, which was still generating a positive result. And now they match to 3 decimal places, 0.453, 0.453. So if we update the interval with those numbers, this is the last thing we'll do. We update the interval with those numbers, 0.4, 0.453, 125. And on the other one we have 0.453, 61328's enough. We've squeezed the window down even closer. So now we have an estimate out to 3 decimal places. That's the method of bisections.